Formula One racing is a sport known for its constant pursuit of speed and performance. From aerodynamic breakthroughs to cutting-edge materials and tire tech, these innovations have not only shaped the sport, but have also influenced the broader automotive industry. So buckle up and get ready for today's video. I'm counting down the top 15 most remarkable F1 car innovations. Let's start with number 15, steering wheel buttons. Steering wheels used to be designed to do just one thing, steer your car. But in recent decades, the empty space on wheels has been used by car manufacturers to add control buttons, such as for adjusting the car entertainment or cruise control settings. While this may seem like a natural evolution, the whole idea of buttons on the steering wheel originated in F1 cars. The ones used in the pinnacle of motorsports today cost at minimum around 50 grand each, and they're used by drivers to adjust virtually everything that they could need, from the differential and engine braking to the brake balance, speed limiters, and even the radio to their team. And this began happening all the way back in the early 1990s. In previous years, the design direction had become used to smaller steering wheels so the cockpits could be more aerodynamic, but with the advent of an increased number of electrical systems, the decision was made to add the switches to the wheel, rather than elsewhere in the cockpit, so it would be easier for the drivers to trigger them. The first buttons added to the face of the steering wheels were the neutral button, which could disengage the engine if the car spun, the drinking button that delivered water through a straw to the driver, and the pit lane radio button. As things developed further, there were times when drivers could adjust traction control, engine mapping, the fuel mixture, and plenty more before rules came into effect to limit what was allowed. And now, while they are simpler in many ways, they're still a daunting prospect to anyone who encounters one for the first time. Number 14. Hot V engine. Everything in Formula One's about making the car as fast as possible, within the rules, and in 1981 Ferrari introduced a new concept into their car of that year. The Ferrari 126C had the company's first attempt at a turbocharged engine, and to boost power and responsiveness further, it was known as the Hot V engine. This means that there's at least one turbocharger in the V that's between the banks of cylinders, and when done correctly can give a significant advantage. Essentially, this design reverses the gas flow within the engine in comparison to traditional V engines, which has a single intake manifold in the center of the V, which is called the cold side. The use of a hot V reduces the distance the air passes from the turbocharger, and after passing through an intercooler, it goes back into the engine intake, and as a result, reduces the turbo lag, meaning the engine's able to power out onto the tarmac much faster. Now, while this technology was used in Formula One more than 40 years ago, it's taken longer to be reliable enough for use in road cars, and it's only started to be introduced relatively recently. The first production car to feature a hot V engine was the BMW N63 in 2008, but since then the Mercedes-AMG GT, the Porsche Cayenne Turbo, and the Cadillac CT6V have. Of course, it's something that only high-performance vehicles will be able to make use of, so don't expect to see it in family road cars anytime soon. Number 13. The Halo. Every racing series has risks involved, not just because of the high speeds that cars travel at, but because of the risks of debris on the track. Formula One has a proud tradition of being an open-wheel series, which means that the wheels are outside of the car's main body, and there's a small cockpit that surrounds the driver's body but leaves the head exposed. The visibility of the driver is one of the reasons that the sport is so popular, because you get a much closer sense of the individuals and you can see them react to events. But this has also undoubtedly increased the danger from objects on the track. Following a series of concerns, especially with the increased speed of the cars due to new designs, the decision was made that new safety features should be added for the 2018 season. There were various options available, but the one that was chosen was the ingenious Halo device, which is the bar that you see surrounding the driver's head, with 3 struts that connect it to the vehicle's frame. Weighing around 20 pounds, they aren't designed by the teams, they're instead provided by external manufacturers, and because of the way they look, they weren't exactly universally liked at first. Also used in various other open cockpit series, it soon became clear how useful the Halo was, and it's been credited with protecting a number of drivers from serious injuries in the years since. Number 12. Active suspension. The ride comfort of a car depends on 3 main factors: the type of wheels, the smoothness of the road, and the suspension. Without any suspension at all, it'd be virtually impossible to travel for prolonged periods, and that's why springs are added to absorb the shock of bumps. Most suspension systems are, however, a one-size-fits-all solution and maintain a static support. An alternative option, though, is an active suspension, which constantly adjusts the vertical movement of each individual wheel and axle, and can substantially improve ride quality and handling if done correctly. The first attempt at the use of active suspension can be traced back to Citroën in the 1950s, albeit in a relatively simplistic way. And the first race cars to feature electronic hydraulic suspension were built by Lotus as a proof of concept in the 1980s. It was, though, Williams, the F1 team, that designed an advanced version of active suspension for the FW14B, the race car that was used in the '92 season, and the FW15C that was used the following year, and it put them leagues ahead of the competition, with in some cases them completing laps 2 seconds faster than anyone else. Mostly thanks to the active suspension, the team won the championship in those 2 years, and the FIA was forced to ban the technology to give everyone else a fighting chance. As it's still never been allowed since, the cars they used in those years are still considered by many to be the most technologically advanced cars to ever race in Formula One. Number 11. Dual-axis steering. Formula One teams are constantly scouring the rulebooks to find any loopholes that they can exploit to gain an advantage, and one of the cleverest was included in the Mercedes car of 2020. From the moment preseason testing began, it was clear that there was something unusual about the car, and the technical director revealed that it was a new feature called DAS, or dual-axis steering. Formula One is very clear in the rules about what can and cannot be altered in a car, but the team had found a way to re-engineer the steering wheel, so while it would turn the car if you rotated it left and right like normal, it would also adjust the position of the wheels if the steering wheel was pushed forward or pulled back. In technical terms, this changed the toe of the wheels, which is the name given to the angle of them against the road, whether they're tilted inwards, outwards, or are straight. Now, normally, each team has to stick to a predetermined toe for the entire race, but the ability to change it gives significant advantages. By pulling the toe to neutral on straights, you can reduce the drag so it can go faster. By pushing it out, you can also increase stability and tire temperature, which further improves performance in the corners. None of the other teams had anything like it and weren't anywhere close to developing a similar system. They lodged complaints about it being used, and eventually the FIA, which is responsible for overseeing the rules, said that it was allowed for the 2020 season, but was already banned for 2021 onwards to prevent it from giving an unassailable advantage. Number 10. The F-Duct. Formula One's got very strict rules about how the aerodynamics of a car work, and with the exception of the rear wing, every piece of bodywork has to be firmly held in place, and this means that the same aerodynamic effects are occurring at all stages during a race and force teams to prioritize certain elements. What works on a straight isn't necessarily the best for corners and vice versa, and in 2010 McLaren came up with an extremely clever idea. Known as the F-Duct because it was visible under the letter F of the sponsor logo, it was a complex series of pipes that would control exactly where the air would flow. At the letter F, there was a hole in the cockpit, and in normal operation this would allow air into the cockpit and into the airbox and would essentially be released through a neutral engine cover outlet. The smart part of this design, though, was down to the action of the driver. All they needed to do was to block the hole in the cockpit with their elbow, and this would cause the air that would normally go into the cockpit instead to go through some pipework and be released through an additional slot in the rear wing. This extra air would then interact with the air around that area and would essentially stall the rear wing, an effect that would reduce downforce and drag and enable the car to reach higher speeds on the straights. Furthermore, McLaren's system could be adapted to each track as the levels of downforce and drag that are needed to differ from venue to venue. Within a race, the Sauber team added their own version of the F-Duct, but by then the FIA had announced that while it was a legal technology for the 2010 season, it would be banned from 2011 onwards. Still, while it wasn't enough to prevent Sebastian Vettel from winning the championship for Red Bull that year, it did lead McLaren to a second-place finish for the Constructors' Championship. Number 9. Paddle shifters. One of the biggest revolutions in engine design when it comes to operating vehicles is the transmission, which allows for the selection of different gears so the engine's performance is far more effective. In road cars, the vast majority of people use automatic transmissions, so they hardly ever think about which gear they're in, or will use manual transmissions, which means you use a clutch and a stick to change gear every time it happens. Now, in motorsports though, a hybrid system is typically used called a semi-automatic transmission, where the action of the clutch is automated, but the driver is still responsible for choosing exactly when the shift in gear takes place, something that gives them far more control over their car's performance. The earliest Formula One cars used sticks, but with semi-automatic transmissions possible because the technology had been developed in road cars, Ferrari introduced a novel design with the Ferrari 640 in 1989, which you now see on every F1 car and high-performance road cars. Rather than having their drivers reach for a stick to change gears, they introduced paddles behind the steering wheel that, when they're pressed, trigger hydraulic actuators and electronic solenoids to do the shift. Other teams then began to introduce their own versions, all with the paddles, some opting for a sequential drum rotation mechanism that's similar to those used on motorcycles, and later electronic throttle control, which allowed the car to automatically match the revs when downshifting. The fear, though, was that these things were getting too close to being fully automated, which would lose part of the thrill of racing. So the rules said that software had to be installed to ensure every shift was initiated by the driver. These rules were rescinded in 2001, when automatic upshifts and downshifts were allowed for the first time, but were banned again in 2004. Today's drivers use 8-speed paddle-shifted gearbox, but interestingly are allowed to use the buttons on the steering wheel to allow a shift to a particular gear, as opposed to having to sequentially shift to it using the paddles. Number 8. Diamondlike Carbon. Everything about the design of an F1 car is about producing the greatest speed, and for most of the components this means reducing the weight as much as possible, while ensuring it's durable enough to at least last for a race before being replaced. For the transmission, this is even more important because there are rules surrounding on how many transmission units you can use in an entire season, and this has led to the development of new materials or the adaptation of established ones to perform in the way that the teams need. This has in recent years seen an increase in something called DLC, or Diamondlike Carbon, which is a type of carbon that exhibits behaviors you'd expect to see in diamond. There are actually 7 different types of DLC, which each have their own benefit, but the main one that's used is called tetrahedral amorphous carbon, which is the hardest and strongest of all of them. When looking at how this could be used in an F1 car, the obvious place was the transmission, where there's a constant material loss in places that moving parts meet, such as the sliding motion of the gear teeth as they rotate. Honda was the first of the companies to look at this and found that the types of coatings used in the valve train were simply not strong enough, so they set about designing a new type for the gear teeth. Their solution was a coating made up of a layer of chromium adhesion, a layer of metal-impregnated carbon, and then a top layer of DLC for strength. Amazingly, this resulted in a 40% increase in durability, while being lighter than what was used before, something that makes all the difference in Formula One design. Moving on to number 7, the J-damper. The forces that are exerted on a Formula One car as it races around the track are immense, with drivers being subjected to up to 6 times the normal force of gravity during braking and cornering, and potentially far greater during a crash. There are mechanisms to try to reduce or at least smoothen the onslaught though, and the design of the suspension is particularly clever. F1 rules state that the suspension cannot be adaptive, but that doesn't mean that teams have come up with solutions that aren't extremely clever. By countering the loads that are exerted on the chassis, for example, it's possible to maintain a more ideal contact between the tire and the road surface, which translates to better handling and speed. Springs and dampers are used to do this, but the spring effects that happen with the high-profile tires are less easy to control. Now, historically, it remained undamped, and there was an element that teams had very little ability to affect during the setup. But in 2005, McLaren changed the game with what they called the J-damper, and after their experience with having the adaptive suspension being banned, they managed to keep this technology secret for several years. Found on the rear suspension of the cars, the J-damper is a mass damper that's able to absorb the loads that traditional dampers are unable to do. It does this by reacting to acceleration and essentially using a spinning weight inside it to counteract any force it experiences. The clever part is that it's actually the force that's exerted on the damper that causes the weight to spin, and therefore convert the energy into motion of the weight instead of acting as a force against the car. This therefore allows for more precise and predictable tire contact with the road. It wouldn't work with the rest of the suspension system and only has a small effect, but in Formula One, where 1/1000th of a second can mean the difference between winning or not, it's one of those small designs that are critical over the course of a championship. Number 6. Carbon fiber. Carbon fiber is a material that's used across a range of industries thanks to a number of properties it has, such as high stiffness, high tensile strength, high temperature tolerance, and very little expansion under heat. It's made up of these fibrous strands that are between 5 to 10 micrometers thick, which is the equivalent to around 1/4000th of an inch, and it's made mostly of carbon atoms that are bonded together in parallel crystals. Now, thousands of these strands are bound together to create a workable length of material, which can then be shaped to however you need. The earliest work on developing carbon fiber took place in the late 1950s and in Japan in the 1960s. Despite several attempts to incorporate it into aircraft engine design, though, the first effective use of it was by McLaren when they used it with the monocoque design of their car in 1981. Offering increased strength for safety but reduced weight for speed, it was a revolutionary concept at the time, and one that's become commonplace in Formula One, with 85% of the bodywork of the current cars now being made of carbon fiber. Because of the synthetic nature of carbon fiber, it remains a hugely costly material to use, and it's one of the reasons why Formula One cars are so expensive. It is, though, increasingly being used in the design of high-end road cars, where the cost to the consumer isn't such a problem. It is, though, far cheaper now than it once was, so it has begun being used in various consumer products where high strength and low weight is a benefit, such as golf clubs, bicycle frames, and fishing rods, as well as other cutting-edge technologies like fighter aircraft and space vehicles. Number 5. Hybrid powertrains. As well as wanting to compete on the world stage with all the promotion and prestige that this brings, manufacturers are involved in Formula One to be on the cutting edge of vehicle design, with the idea that eventually some of the technology that are created for the race cars will trickle down into the designs of road vehicles that can be sold to millions of people. The car industry has, of course, gone through a massive change over the past decade or so, with a shift towards design that pollute far less and in many cases rely far more on electrical power. This put things at odds with Formula One, which as recently as 2013 saw teams using a 2.4-liter V8 engine design. So to appease the manufacturers and show that the sport is able to move with the times, completely new engine regulations were brought in for 2014. Known as the hybrid powertrain, it features a 1.6-liter turbocharged V6 engine alongside several systems that were designed to harvest energy from the heat being produced and when braking, which could be further developed for extra power at certain times during a lap. When this new concept was introduced, there were 3 engine manufacturers, Mercedes, Ferrari, and Renault, and it was the Mercedes version that was by far the most effective. With regulations surrounding how much development can be put into an engine each year, this gave the teams running the Mercedes hybrid engine a major advantage over their competitors, and saw the Mercedes Works teams winning the Constructors' Championship every year from its introduction until 2021. Number 4. The Double Diffuser. When you look back over the history of Formula One championship winners, there's a couple of years that stand out with less familiar names. The last time this happened was in 2009, when Jenson Button won the Drivers' Championship with his team Braun GP. Now amazingly, this was the one and only season that this team competed, having previously been known as Honda and subsequently being bought and turned into the Mercedes team. Its success was all down to its owner, Ross Brawn, who with his design team created one of the cleverest and most controversial additions to a race car in the sport's history. The rules of Formula One constantly move back and forth in the way that the aerodynamics of the car affect the air that passes over it, and the way this influences how closely another car can follow behind and potentially attempt an overtake. New rules that were brought in for the 2009 season aimed to make the racing a more exciting, and this had the consequence of reducing the downforce that was attainable by conventional means. This changed the way the cars handled, so teams began to try to find ways that could make up for this loss, and they did this by designing a new type of diffuser. This is a device that's installed in the rear of the car and smooths the way the air beneath the car is mixed in with the ambient air around it as it passes by, and when done properly, it can generate downforce. By the time the first race of the season, Braun wasn't the only team to have a double diffuser, which was a far more complex type of diffuser than teams had used previously, and this led to the remaining teams lodging complaints about those that had focused on this area for the development. The FIA, though, ruled that it was legal, and you only needed to look at the results of the races that year to see how impactful it was, and how Braun's edge began to waver as the other teams caught up and designed their own versions. The team's lead driver came in first place for 6 of the 7 races at the beginning of the season, but only made it to the podium twice in the final 10, being unable to win any of them. By that time, they had taken such a lead in points that no one else could catch them, and history was made. Number 3. The DRS. The rules in Formula One are very strict when it comes to the aerodynamics. We've gone over that, and specifically state that no moving parts are allowed where their primary purpose is to alter the aerodynamic profile. There is, though, an exception to that rule in the rear wing, with a device called the Drag Reduction System, or DRS for short. The sport has long had a problem surrounding the advanced nature of the cars and the way that they create what's known as dirty air in their wake. This means that there's only a limited time a car can closely follow another one before experiencing increased wear on the tires, but by having to leave more of a gap, it becomes far more difficult to overtake. In many races, this can lead to a virtual procession of cars from the start to finish, and obviously doesn't create the most exciting spectacles for the fans. First introduced into Formula One in 2011 and several other racing series since then, the DRS aims to add more unpredictability into a race by allowing drivers to control an adjustable flap in the rear wing that, when activated, significantly reduces drag and enables them to reach a higher speed for an attempt at an overtake. In some cases, it's estimated to increase the speed by as much as 7.5 miles an hour, which can make all the difference. Crucially though, it can't simply be activated whenever a driver wants, and is instead limited to certain predefined zones on the track. You must be also within a second of the car in front to be able to use it, and in most cases is a virtual guarantee that an overtake can happen. The DRS hasn't been without its controversy though, mainly with claims that it artificially alters the race result. But there's no doubt that it has made the races more thrilling to watch, and anything that helps bring more spectators to the sport is beneficial in the long run. It's also another technology that's starting to be seen in road cars too, albeit only on high-performance ones that are intended for use on tracks too. The first production road car to feature a DRS system was the McLaren P1 Coupe, which was produced in a limited run of 375 vehicles, and then later the Porsche 911 GT3 RS, which was revealed in 2022. Number 2. The Kinetic Energy Recovery System. When new engine regulations were brought in for the 2009 season, there was an increased aim to Formula One to be more efficient with the energy that's produced to help manufacturers develop technologies that will reduce carbon emissions. One of the breakout things that was developed has influenced countless road cars since its introduction, and it was the Kinetic Energy Recovery System, which is more commonly known by its acronym KERS. First revealed by a company called Flybird, the basic principle of the system is that it's able to convert this kinetic energy to electrical energy when a vehicle is braking, and this can be stored in several ways to be deployed later on. Usually all of the kinetic energy is turned into heat within the brakes, so this is harvesting what would otherwise be wasted and makes things more efficient as a result. Originally, the Formula One teams were allowed to store this extra energy in either a mechanical form such as a flywheel or in electrical form in a battery or a supercapacitor, and it was the McLaren Mercedes team that would be first to win the race with a KERS-enabled car. Despite its seeming success, all the teams agreed not to use a KERS system in the 2010 season, but it was reintroduced in 2011, and with wider rule changes being brought in for the 2014 season, it became a mainstay of F1 car design since. Today, the KERS system is able to hold 160 brake horsepower or 120 kilowatts of power, and once charged, can be deployed by a driver whenever they want during a race to give an extra boost to hopefully overtake or at least catch up with the front car. With the technology having been developed to such an extent, it's been a natural step for it to be introduced in other vehicles too. Many other racing series use a KERS system, but car manufacturers are also including variants in road vehicles. And in London, some buses even feature a flywheel version of the KERS, which is said to improve their fuel efficiency by as much as 20%. Number 1. The Fan Car. Today, Formula One cars across the teams look virtually identical to each other, apart from a few seemingly aesthetic differences. But one of the things that makes the sport so interesting to enthusiasts is the way that engineers can interpret the rules in entirely different ways. Throughout the history of the sport, there have been a number of unusual-looking cars that truly stand out. But perhaps the most inventive of all was the Brabham BT46, which was entered by the Brabham team for the 1978 season. The B version of the car, which raced in the Swedish Grand Prix of that year, was known as the fan car because of the huge fan at the back. Said to be installed as a way to increase cooling, it also had the secondary effect of extracting air from beneath the car and therefore majorly increasing its downforce. Its driver during that race, Niki Lauda, won the event comfortably, and the other teams immediately called for an investigation into whether this new design was even legal. The FIA ruled that it was perfectly fine and that Brabham could race with it for the rest of the year, but that race in Sweden was the one and only time that it would ever make it to the start line. Despite being an ingenious design, the team owner was Bernie Ecclestone, who was in the midst of a power grab within the sport. That year, he had become the chief of the Formula One Constructors Association and felt that continuing to run the controversial car could cause too much friction with the other teams. Ultimately, this ended up being the right commercial call for him, as he went on to become the head of Formula One for 30 years, in many ways making the sport what it is today. But for design enthusiasts, it's still a shame that the full potential for the fan car was never truly seen. I'll see you guys next time.
Watch our Vehicles playlist for more top 15 videos about amazing vehicles. Sit back, relax, and binge watch all of our best vehicle videos.
Thank you to our channel members.